Okay. All right. So thank you everyone for coming. My name is Rakesh. I'm president of Falco eMotors. I'm going to give you a quick overview of our technology, what it takes to convert a trike, right? Especially we're talking about trikes, we're talking about bikes. Today, 70% of our conversion is on trikes. That means 70% of systems we sell, they go on trikes. 30% of our systems go on bikes and tandems, so on and so forth, right? So trikes is one of our major areas of focus in terms of conversion. We do all the trikes, we do cat trikes, HP, ICE, etc. 22% of our conversions go into onto cat trikes, about 11% on ICE, 11% on HP, and then 11% on Trike. So those are kind of major, and then you have the remaining conversion. So we cover all the trike, even all trike brands today. So the agenda is, so I want to talk about, one is ensuring safety. How do you safely install a Falco system? That's very important because that's the first step in being able to get the Falco, to get a trike converted. Then we're going to talk about safe installation practices. I have some very good slides on electric bike technology comparisons. So there's a lot of talk about mid-drives, geared motor drives, and direct drives. And there is a lot of questions about it. And also we have seen I think since 2011, we have seen we have seen popularity of mid-drives, right? So are they the right direction to go? So I have got some very strong opinions about it. I would like to share that with you. And before we do that, I want to go through quickly the Falco e-bike components. So we are really, we like to make things very simple. We like simplicity. We like less number of components. And that is the driving philosophy. We only have one motor today, right? One motor and 5 batteries, right? So if you see here, so we have one motor. Oh, it's even better. Wow. A millimeter makes a difference. Okay. So one motor and 5 batteries. We have Li1, Li3, Li7, Li9, and Li11. So we have them also on the table here. So you're welcome to come to the table after that and look at that. We have, so in terms of controlling the motor, we have got, you can control, we have a wireless console. We were the first company to have a wireless console in the e-bike industry in the world. We launched, it is based on AND+ technology. We also have apps. We were also the first company in the world in the e-bike industry to have our own apps. We showcased our app in 2011 in Eurobike. And we also have a wired plus minus. So there are 3 different ways you can control the motor on your trike. We have basically only 5 systems. In the catalog, there are a lot of variations, but in a sense, we only have 5 systems because we have 5 batteries. So you can say one motor with 5 batteries, basically it's 5 systems. And that too, you can see that we have, when we couple with 36-volt batteries, we call them 500-watt systems because the motor automatically reduces the power to go from 750 watt to 500 watts. That is an automatic change inside the motor that when it detects it is a 36-volt battery, because our batteries are not meant, for 36-volt batteries are not meant to run higher power. So we automatically throttle down the power of the motor with 36-volt batteries. With the 48-volt batteries, we are able to deliver more power. So you can see with, and when we couple with a battery, we take, for example, Li7 battery, so that system becomes F7.7. The first digit stands for the power of the motor. So 5 is 500 watt. And then the second, the decimal or one tenth is the battery. So for example, the 7.7 is Li7 battery, 7.9 Li9 battery, and 7.11 is Li11 battery. So these are some of the components which are included in the system. You can see, we have the wheel, the wireless module, the throttle, the wireless console. This is a standard system configuration, and we'll go through some of these things in detail here. Console charger, torque arms, battery holder, battery keys, charger, etc. We will start including a junction box also as a part of the standard system because so people don't like to be able to take out the plugs and charge the console. So wireless console is easier. You can leave it on your Trike without having to take it off. Today you have to take off the console to charge it. So with the junction box, we are able to charge it without a problem.
Does that mean you have to run a wire from that console to something?
Yes. Yeah.
Not permanently, though.
Permanently, yes. Yeah. So the simplicity system, we just take the wireless console out. So 3 components come out: wireless console, wireless plus minus, and the charger. So simplicity, and it's replaced with a wired plus minus, right? So comparing the 500 watt system versus 750 watt systems, people ask a question, what should I choose? So what we have done is we have mapped on 4 dimensions: range, price, speed, power, and lighter. So you can see E5.1 system, it's lighter, it has got less range, less price, and less power. Whereas a 750 watt system, it has got little more weight, maximum range, higher price, and higher power. So that's a very quick comparison of the 2 systems. So the motor, this is the exploded view of the motor. We have everything inside. We have the electronics inside. We have sensors inside. So the motor is unique in terms of the fact that we are also the first company in the world to use 5-phase technology. The reason we use 5-phase technology is the fact that when you run out of battery power, the motor has 0 freewheeling resistance, and that is very critical, where you should not be able to feel the motor when you're pedaling. Also, it has got added advantage that we can actually get more power out of the motor compared to a 3-phase motor. So we have inbuilt torque and speed sensors nowadays in the hub. That means we are able to amplify the human power very, very intelligently. So we are not about the raw power. We are really about very natural, seamless operation of the motor with the bike. You should not feel that you're being overpowered by the motor. This is another graphic to show the cutout of the motor. We have so disc brake compatibility, 11-speed compatibility, integrated torque sensor, 16 integrated sensors, and today we have a 12 millimeter hardened, axle, which is quite remarkable because we can really, even a very heavy rider can ride without having to, you're smiling, I can see that.
On the 11 thing, you and I have that conversation.
Yes. Yeah, I think it's a good point. Mark's point is that 11-speed compatibility is not really true. It's more like 10-speed. The hub we use is a chosen hub. Now it is, according to them, mountain bike 11-speed compatible, but Mark says that's not true.
Yeah, you can fit the Shimano big cassettes, the 40 and 42 low gear, because the actual low gear fits around the free hub body. But like 1136, 11-speed will not fit 10-speed, or unless you do the big.
Thank you, Mark.
Yeah,
thank you.
sorry,
No, thank you for that. So today we have got, we can set for European speed limit, which is 15 miles per hour, or 20 miles per hour, or 28 miles per hour. 750 watt max power output, 45 newton meter max torque. Those are the specs. We do wheel sizes. We have done 16-inch wheel size, but that's very difficult for us to do. We still are able to do some of them. So 16-inch all the way up to, we have done wheels even bigger than 700C for some custom bikes. The wheels are built in the US, and one of the builders we use is Velocity up in Michigan. We use the Cliffhanger and Arrowheat rims today to build the wheels. We use Sapim Strong spokes and special nipples. So nipples are locked in with the, and I think Larry thinks that we should do better on the wheels.
Just turn those heads in instead of out.
Yes, that is true. Thank you. So, sorry. So Larry says that the way we are building the wheels, he wants the spoke heads to turn in instead of out. So, and that's a discussion which he says, and he's right in a way that it can make for a stronger wheel. And today, our wheel builders are building with the heads in. So that's the point he's trying to make. It's a debate, which is, we need some more testing. No. Yes. So dropouts, our motors, standard motors they fit in vertical dropouts. Most of the trikes today are 95% are vertical dropouts. 135 millimeter is what we stock. 32 spoke holes. We can do any number of spoke holes, 32, 36, 40, etc. We also are able to do non-standard configurations, 145, 160, 170, 190, etc. So batteries, so let me go quickly through the batteries. So we have two flat packs, Li1 and Li11. They are 36 volt and 48 volt. You can see the amp hours. The peak power for the 36 volt battery is about 1000 watts and 1400 watts for Li11. Watt hours 400 for Li1, 500 for Li11. Now the storage temperature is between -20 to 35 degrees Celsius. We get a lot of questions how to handle the batteries. And the answer is that you want, the batteries are very much like humans. They don't like to see extreme temperatures. So if we can store them at room temperature, it's a great thing. They don't do well in extreme cold. They don't do well in extreme heat. The extreme cold, the battery will shut down. Extreme hot, the battery also can shut down because of the protection inside the battery. The cycle life is more than 500 cycles, and normally we are using either Samsung cells or Panasonic cells based on the availability to build these batteries. So real quick, and this will be emailing you if you're giving your email address. We are happy to, if you have a notepad or you give us your card, we'll be able to email all this to you. Whoever has registered for the workshop, we will be emailing this PowerPoint to you. So here's some information, how to check the status of the charge. So the way we have, it's same on almost all the batteries. Full charge is 3 green and 1 red LED. 75% charge is 2 green and 1 red LED. 50% is 1 green and 1 red, and 25% is 0 green and 1 red, right? So this is pretty consistent. You can see how we are checking it. There is a button next to the gauge where we can check it. These are the dimensions of the batteries. This is the on-off button for Li1 and Li11. We have also a fuse, accessible fuse on these batteries. Rarely the fuse does blow because people, it's possible that the battery is at very low voltage and you're trying to draw a lot of power out of it. So, but we have accessible, it's a 15 amp dual automotive fuse. The battery serial number is on the back. Battery voltage and capacity is also on the back. So everything, all the components we have are serialized, so we are able to track their production, their warranty, etc. These are dimensions of the battery holders. Again, I don't expect you to note it down. We'll be emailing this information to you. So you can see the battery holder. You can see where the key is located. So we have a battery holder, the key lock, the power cable, and the keys. So this is essentially what comes with the battery. So here are, we have a lot of questions how to install the battery on a rear rack. We don't supply the rear rack. We have, normally you can mount the battery on any rear rack. So here is the hole pattern you can see. So you can see that there are 4 holes. They're all M6 bolts. We provide the hardware along with the battery holder. And we have 18-inch long power cable. It's little more than 18-inch, but 18-inch long power cable which comes with the battery holders. So, and the battery holders, it comes in 2 parts, and there are 7 self-head threading screws which hold the battery holder together. So this is a little complicated than the other batteries, but the rear rack batteries have got additional assembly time than the other batteries. So this is the complete battery in the battery holder. As you can see, it's about 13.5 inches long. So here are some examples of how this battery has been used. You can see on bikes, you can see on a KMX behind the seat, you can see on a Trike on the side, and then you can see on a bike rack. And here you can see on a tandem how it's installed in the back. And here is our Li3 battery. This is about 13.5 inches long, along with the holder. So the dimensions again we'll be emailing them to you. This is also available on our website, but this particular presentation will email as well. Same exact ways to check the status of the batteries. So let's see here. So there is a battery on-off switch on the side, and we have so that's our Li3 battery. So you can see, so we have a slot here on the side to go into the battery holder, and then you have an on-off switch on the side here. So, and then this is the wire, this is the gauge. So you can check the status with that. So on the bottom of the battery, you have a battery output, and then you have again the fuse compartment. So you can check the fuses as well. So you can see here on the bottom of the battery. So this is where we tap the power output through the holder, and then we have the fuses here, which we can replace. But normally you don't have to, but sometimes you can. So the battery holder has got quite a bit of leeway in terms of installing. There are 2-inch slots you can see there, and so it allows you quite a bit of flexibility to adjust where the battery holder can be mounted. So we do have an example here on a Trike 559 how the battery has been mounted. This is a little bit non-standard because we have used rivets to rivet inside the frame. Normally people use, or dealers like to use TerraCycle mounts as well. So here are some examples. You can see how, so that's on a bike. This one is also on a Trike 559. You can see how that has been used with this has been used with a TerraCycle mount, and then you have another example over there. Here is another example. You can see how the battery is mounted. So the triangle is pretty wide, so you got a lot of room to mount the battery. So this is pretty simple to mount. This is our Li7 battery. So it has got on-off switch keys similar to other batteries, and these are the dimensions for the batteries. About this is 13 3/4 inch long, and it has got the battery gauge on the side, and also it has got a USB charging port. So this is the only battery which has got the USB charging port. Other batteries don't have the USB charging port. So this is the holder. It has got 3 slots, 1 3/4 inch slots. Power cable again is 18 inches long on all of the batteries. You can see the power connector. And similar to other batteries, you have a switch to check the gauge of the battery. So there are different ways to check the gauge, how much capacity you have. You can see it on the app also, how much battery capacity is left. You can also see it on the wireless console, and you can also see it physically on the battery itself, that how much is left. So Li7 battery also has a tab with which you can use to remove it. Here are some examples. You can see here how the battery is mounted on the side of the trike. So this allows for fantastic stability because you have a very low center of gravity. Here is on a tandem. You can see how it has been mounted on a tandem. We do quite a few tandems, and the reports are that it's an exceptional riding experience. Here is a unique way to mount the Li7 battery. Some dealers use it. They mount it in front of the seat. So mostly on cat trikes you can do that, is mount the battery. So the cable becomes a little longer in this case. You end up having a longer cable than than the regular. So you end up having an extension, power cable extension. This is on a fat bike. This is on a tandem. This is on a cargo sort of bike. We have a front wheel drive, so this is a very different system, front wheel system. We don't sell any front wheel system at the moment, but this was when we sold front wheel system. This is a front wheel system with the Li7 battery. Here is on a hand cycle, so unique. Again, people find unique applications of how to mount the batteries. Here is on a cargo bike. You can see how it's mounted on the bottom here. So it's fantastic with a 20-inch wheel and the battery. Here is on a fat bike. Unique. This is a 160. I think it's a 170 millimeter dropout motor. So you can see the battery there. Another fat bike. This is another trike, fat trike. Now let me come to Li9 battery. Now Li9 battery is a little different. The difference between Li9 and Li7 is simply the shape. They have the same specifications, same capacity. Both of them are about 672 watt hours. This is a little longer. You can see it's 14 3/8 inches. It has got on-off switch on the cradle. So that's another difference we have with respect to Li7 battery. You can see the dimensions. It's about close to 4 inches tall, and 3.5 approximately inches. So this battery holder is not as strong as Li7. So that's one reason people prefer Li7 battery. But we sell a lot of Li9 battery because people prefer the shape of it. It's more stylish, more sleeker look than our Li7 battery. Now we have changed the design a little bit. We have added metal reinforcement on the battery holder itself. I don't know whether you can see it. but there are metal clips which are added on top of the plastic. We also have added, we provide optional bottom pads as well to enforce the battery holder. So here are some examples of, so this has been mounted simply on a rack. So this was an odd way to mount it, but then again you can mount anything on a rack, right? So here you can see it's mounted similar to this battery here as we have mounted it. This is mounted sideways. Again, not the most optimum way to mount it, but you can see how it still is a good way to mount it because it keeps the center of gravity pretty low for riding. This is on a fat bike and this is on a HP, you can see here. So HP has a special mounts for these batteries. We don't have those mounts, so but they come from HP, and then we can mount directly the battery on that mount. This is actually HP with dual battery. Let me quickly talk about our console. Now the console is actually quite simple. It doesn't have a lot of information, but it has a very basic information. You can use the console to change the assist levels. And it shows speed. It shows trip mileage. It does not show you, so it's more of a tripometer. It's not an odometer, right? It does not keep track of the mileage from the beginning of time. It shows battery voltage, which is in a way you can look at the status, and you can set the wheel circumference. So those are the really only functions this is able to do with the console. It's based on N+ wireless technology. It does need to be paired up. Normally it pairs up at power up automatically, but sometimes if it doesn't pair up, then we have to manually pair it with the motor. So the console has essentially three components. When you order a console, you have the console, the plus minus, and then you have the USB charging cable, which is used to charge the console. There's also an on-off button on the back of the console, so that can be used to conserve the battery. Or in the winter, you can turn it off and store it. So the Falco, let me spend a few minutes on so 35 minutes, I'm through 72 slides, so I'm not doing too bad. So let me spend a few minutes on this Falco smartphone technology. So we have, so this technology we have developed over years. So this has got a total of 6 screens. So you can download it. It's available freely from App Store or from Google Play Store. It has got a total of 6 screens. The main screen here essentially allows you to, again, this needs to be paired up with your, just like you will pair up a BLE device, you will need to pair up the app with the motor. And you can see here, this is the connection disconnection button. It shows you the connectivity with this. This shows you the assist levels. So when all bars are green, that means it's level 5 assist. This shows you essentially the amount of energy you are consuming or you are putting it back in the battery. So these are supposed to be Falco wings where it shows you how much energy you're consuming. So it goes green when you're putting the energy back into the battery. It goes red when you are drawing the energy from the battery. This shows you your status, how charged your battery is. And then you have the speed and you have time and distance. So this is screen number 1. Second screen is the eDRIVE data. So this is an important screen for diagnostic purposes. We are able to see the battery voltage, the battery current. So you can actually see these numbers while you're riding it. It shows you the battery capacity, instantaneous watts. How many watt power are you actually using from the motor? It shows you how many watt hours you have consumed, how many watt hours are remaining, It shows you efficiency, watt hour per mile, how much energy you're using per mile. So that's a very important way to determine the efficiency of your riding. It shows you miles range remaining. So if you're being very efficient, you can actually get a pretty good range. And then you have got here, it shows you, we also display what is called motor temperature, and we also show the assist level. So these actually two numbers are shown here. They toggle every 30 seconds between motor temperature and assist level. And this is important. We have at times, if you get an error, for example, this is a fatal error. When this becomes 1, then there is nothing can be done in the field. The motor has to come back for repair, right? So this is an important part where if it becomes 1, we call it edge sensor error. So we can quickly, 99% of the problems we can diagnose through the app. We don't need any fancy equipment to diagnose it. We can just look at the app and we can see what's wrong.
But it has to be, the wheel has to be sent back.
Yes. So when it is 1, that means it's fatal. There's nothing we can do or bike shop can do. So it's a simple binary decision, 0 and 1. We don't have to go through a long list of diagnostic purpose, training to figure that out. So this is one simple screen for adjustable speed screen. Sorry, this is cut off. So you can lock or unlock the speed limit. So when you unlock the speed limit, it can go up to 28 miles per hour, and you lock it down, it goes to 20 miles per hour. So it's only available for US options. Europe, it's 15 miles per hour and you can't exceed it. So here is one important, what we call torque sensor setting screen. There are eight parameters. So this is an important part. This is the profile you can set, but really two parameters are most important. Rest of them you can pretty much ignore today because we have already pre-programmed a lot of stuff based on last many years of data. So the two parameters which are important, one is the dropout offset. So this is more like we sense the threshold of your torque, what torque you are producing as a rider, right? So higher the number, that means you have to have higher tension, higher torque you have to generate from your pedals in order to activate the motor, right? So if I lower the number, that means I have to put less effort, right? The other one is we call a torque multiplier. So these two numbers are most important. You can pretty much ignore these numbers, 1, 2, 3, 4, 5, 6 at the moment, because all of that has been taken away from the equation with the introduction of the speed sensor in the cassette, right? It's still available, but they are not as relevant as they used to be when we didn't have the speed sensor integrated into the cassette. So the torque multiplier allows you to again control how the human power is being integrated into the electric power. So that's a very important aspect. For example, if you are an athlete and you want to actually use minimum of motor power, you can lower that number. You can put it even 0, 1, right? And that'll give you less power, right? If you want, you can go up to 12, number 12, which will give you a lot more effect.
How does that relate to the power levels that you've picked, the assist level?
Right. So the question is, how does that relate to the assist levels? Now, the assist levels all clamp to a certain amount of power. For example, assist level 1 give you 100 watts of power maximum. Assist level give you 200 watts. Assist level 3 will give you 300 watts. Assist level give you, so on and so forth. So 5 levels will not give you more power than that, right? But within that power, how that power comes on, you can actually control it. You can control it. Okay, maximum is 100 watts. Maybe I don't want to use 100 watts in my assist level. So I say, okay, I'm going to reduce my multiplier so that I'm only using 50 watts of available 100 watts of power. So it gives you real control over how human power is mixed with motor power. We believe we are the only company today in the world which can do this smartly and intelligently. And then we have this screen here, which is mainly for diagnosing the torque sensor. You know, we are looking at only this number. These three are not as relevant. We are only looking at this number. We want to see this number on the app, and we want to see that when you push tension on the chain, this number goes down. And normally we are looking at 30 count variation. So if it's a very strong rider, they can change this number all the way down to 60, 70 counts. So this also shows you how much leg power you have in your legs. So you can do a quick test saying, okay, how exactly is this number reacting to your push on the pedals, right? So if somebody is a very weak rider, and you can see, okay, they can only move 10 or 20 count, whereas if you said you can move 60 or 70 count, you know that you will have to make the torque sensor more sensitive in order for the drive to do the work. And then we have ability to also change the assist level itself, right? So you can go in and modify the assist level. We say, okay, this is 100 watts, this is 200, this is 300, this is 400, etc. But you can even further clamp it down. We have had cases where we have had riders who don't want to go more than 10 miles per hour, right? So this is a great way to clamp down the power. This is also a great way to increase the power. We can, let's say you don't want to have 5 levels, you only want to have 3 levels, right? So you can also do that using this screen here. So you have real tools in your hand to be able to do a great amount of customization. For 90% of the riders, you don't have to do any changes. You know, default settings are good. But there is also the 10% of the riders who are special need riders. So you can go in and do the changes in that respect. All right, so
Is that any different than doing it with plus minus and looking at the console?
yes. So as I said, 90% of the riders should be happy with these assist levels, but then there's a 10% where they have special needs. They want to have more power. For example, they want to say, okay, level 5, I want more power, right? We're delivering, let's say 500 watts. We want to actually have 600 watts or 700 watts in level 5. So you can actually increase it from 16 all the way up to 20. You can do the same thing with the turbo. You know, I can increase each by 25%, and then I can have a very different setup. And then operating the app is real simple. You can slide your finger. So sliding the finger this way. So sliding up and down will allow you to change the levels. And then if you slide on the empty space by side, you can go to different screens, right? So the operating the app is quite simple. You can change the assist levels by having your finger slide up and down on the first screen, and then you can go to the next screen by sliding right or left.
What does it say when it says select motor type first?
Right.
What do you mean select motor type?
So the protocol, the steps is that we end up. So let me get to this screen here. In order to access the assist levels, we end up selecting the icon. So this allows the app to identify the motor, and then because this is normally not loaded settings, so we are actually using a command to the motor that we select the image, and then the levels are loaded up on the app, right? So this is just an additional step we have to use, because this is normally we are not gathering the information from the motor at all times. So we also have additional 7 settings which you can access. So if you see, on the side, on the top, whatever you can, right hand side, You can access additional settings. We have 7 additional settings, but really for the end user, only 2 settings are important. One is what we say is the CRM settings, right? All other are for diagnostic purposes. You can select, so CRM settings and sensor selection. You can also, battery type selection is normally automatically. So motor will automatically know which battery it's using, but you can always go in and identify the battery you have, right? So 2, setting the relevant CRM settings to check the wheel diameter, and the sensor selection. Now, we are the only motor technology which allows you to operate the motor with a combination of sensors or with individual sensors. For example, you can also operate the motor just with the speed sensor only. It's a different kind of feeling, but it is for those riders who want more power. Again, the last 10%, 90% of the people are happy with the default settings, but then the 10% is, we have had a rider who said, I want more power. So when it says you want to feel more power, they want to they really want to, feel the raw power, as we call it. So if you want to feel the raw power, you switch the drive over to speed sensor and you can feel the raw power. It consumes a lot of power from the battery, but you can feel the raw power. So CRM settings, you can select from the various wheel options in the app. We don't have ability to put the exact number in the app at the moment. So it's kind of approximate in terms of the wheel sizes. So sensor selection, sorry.
I had a question about the size, the wheel size.
Yeah.
How do you deal with the wheel size? We had, wasn't this system, but you still have to program the size of the wheel, a 26 with a 3.8 fat tire. It's not a 26. Or your
Correct.
miles and all are going to be all.
So that's a very good question. So how do you take into account very special tire, right? It's a 26-inch wheel. It has got 3 big tire. So we unfortunately cannot take that into account because we have approximate wheel sizes. We are working on the next level of the app where we can actually put the precise CRM number.
That's about the same as the 29.
I programmed it as a 29, and
Right.
I said, go somewhere where you know the actual miles and measure it, because otherwise it'd be all off.
That's a great solution, right? So you know it's closer to 29-inch than the 26-inch. So thank you for sharing that. That's a great solution. You can pick the 29 inches. Thank you. So here is wired plus minus. This is another interface we have available. People who don't want to use the wireless console, they can use the wired plus minus system. So wired plus minus, we call it all-in-one. It allows you 3 assist levels, 1, 3, and 5. It allows you 3 regeneration level, -1, -3, -5. It has a built-in, if you hold the plus, it gives you throttle feeling. And if you hold the negative, it gives you regenerative braking. So most of the functions you can carry out with that.
Does it have an indicator?
It has an indicator, correct. So it has a LED indicator. So you have got 5. You have a green LED. So if you can see here, the only indicator we have is the 5 lights. They turn green.
If you get your phone on the handlebar, will it tell you where you are too?
Yes.
Okay.
Yeah. Yeah. So the 5 green LEDs basically, so when you're in green category, that means you're in positive assist level. That means the motor is going to assist you. And if it is red, that means the motor is going to be a regeneration. It's going to be giving energy back to the battery.
When you say wired, it's wired all the way to the back.
Yes. So it hooks up like that. So you can see we have got, it can be hooked up through the wireless module and directly to the motor, or it can be directly hooked up bypassing the wireless module to the motor.
Why do you need the wireless module if you wired it?
So the wireless module, people still want to have the connectivity with the phone. So people still want to be able to use their phone and use it. So you can see here how it is displayed. You can see the red LEDs 1, 3, and 5. Low, regen, medium, high, and then you have assist levels, low, medium, and high. So, so we talked about the operation. Single click is +1, double click is +3, and triple click is +5. Similarly with negative, then hold the positive for throttle, hold the negative for regen. So the junction box, which is basically allows you to eliminate the charging of the console. That can be added to all the systems. It also allows you to, if you have a brake sensor, you can be installed. We don't recommend the brake sensor simply because it causes more trouble than it is worth. Because you have a lot of other ways to use the regen, but we do have that input available, and you have access to throttle input when you use the junction box. Throttle can be hooked up directly to the motor, but if you use a junction box, then you have to hook up the throttle to the junction box. So we also have, instead of in addition to diagnostic through the app, we can also, sometimes it's not possible to diagnose with the app that we have something wrong with the wireless communication. So we also have what is called a manual troubleshooter. The manual troubleshooter can be hooked up between the motor and the battery, and it can tell you whether something is drastically wrong with the motor. So you can see if you hook it up, all 5, or it has got 8 LEDs, they all light up. That means everything is good from a hardware standpoint. This LED indicates your battery is good. This indicates we have 3 cables from the motor: battery, 4-pin, and 6-pin. So you can check whether all connections are good. So 4-pin cable, those LEDs light up, and then 6-pin cable, those LEDs light up. So when all are lighted up, that means the motor hardware is in good shape. So we also have a programmer available. This again allows you, if there's a drastic change in the operating system of the motor, we don't require it. It's not required. Our system has been extremely stable and performing quite well for past several years. So, but this is available. This is available also to change the motor, because we as you can see if you come to our booth, we also have integration with virtual reality. So today, in order to change the motor from just being an outdoor use to indoor-outdoor use, we end up changing the operating system of the motor, right? So then it can be used both for indoor as well as outdoor mode. So if you haven't checked it out, please come to booth 205 and ride the virtual reality integration. It's quite extraordinary. So ensuring safety in terms of the motor hardware. Yes, sir.
When you say indoor, you're talking about like on a wind trainer?
Correct.
So you can change the mode from in wind trainer and then change it back to outdoor.
So yeah, so the motor itself will act as a load if you use our indoor-outdoor eDRIVE. So you don't need anything extra. You have just, we have the rollers, you roll, the motor itself acts as a load. And it can hook up to the virtual reality program like a Zwift, and the motor actually is trying to simulate the road. So if you're going uphill, the motor is going to become stiff. If you're going downhill, the motor is going to become easy, right? So it is going to simulate. So you could be, you could simulate cycling in Paris. You could simulate cycling in New York City. You could simulate cycling anywhere. So when that program comes through the PC, through the virtual reality, the motor will automatically simulate the road conditions. So installing, the motors have an axle with a part number. You can see here, it's a 12 millimeter diameter axle, 10 millimeter flats, 1 millimeter fine thread. It is a chromoly hardened steel, and it has got some numbers on the flats. So those numbers, when you're installing the wheel, it has to point to the back. The hardware which comes with the wheel, we have got 2 M12 nuts, we have got 2 washers and 2 torque bars. So you can see here, M12 nuts, 2 plain washers and 2 torque bars. We also provide torque arms. Torque arms are required for almost all the installations. So we provide 1 set of torque arms. You don't need 2 sets of torque arms. 1 set is more than sufficient. And here is an example how to install it. You can see here. So we have got M12. We have got 2 washers. We have got the base torque. Base arm of the torque arm set. This is torque arm 1. This is the M5 bolt. So all this comes with the system, right? So this is required to stabilize the axle. If the axle is not stable in the frame, then you run the risk of having an erratic operation of the assist. Yes, sir.
The 5 millimeter.
Yes.
Where can you mount that if there is no mounting hole?
Yes. So in that case, you end up using a small hose clamp. So you can see here, you use a longer arm 2. So you can use longer arm 2, and there's a long slot, and you use a small hose clamp to clamp around the pipe on the frame.
They make a coaster brake strap that works the same.
Yes. Yes, sir. So the M12 needs to be tightened to about 40 Newton meter torque. So that is a requirement for safe installation. We also recommend that you can use a blue Loctite on the threads, Loctite 242. That also is a good one to use. So second set of torque arms, people ask that quite a bit. We don't need a second set of torque arms. One set of torque arm is more than sufficient to stabilize the axle and hold with the frame. So the dropout, most of the trikes have got very good dropouts. Normally we have run into trouble with bicycles, not so much with trikes, because there are bicycles which may have only like a 8 millimeter or 10 millimeter dropout, and they are shallow dropouts. In that case, maybe you need a second set of torque arm. But on trike, we have never seen dropouts which are shallow. So most of the trikes have very strong dropouts. So here you can see this is HP Velotechnic 12 millimeter deep, beautiful dropouts for the motor. Yes, sir.
Are you going to be doing anything for through axles?
So we do have a through axle. That is the through axle right there. So this is our through axle motor here. It's got a 12 millimeter through axle. So we have not started shipping it yet. We haven't announced it officially, but we are ready with the through axle design. So let me, so here is the guidelines for all trike brands. So we do recommend torque arm to be used for all aluminum frames. Torque arms are not required for chromoly frames. So if you have a chromoly steel frame, you don't require it. But again, you know, it comes with every system is shipped with 1 set, so you can always use it. But if for example, the TerraTrike Rambler is a steel frame, so you don't need it's a very stiff frame, so you don't need the torque arms there. So here is a comparison. We want to talk about electric bike technology comparisons, right? So this is a quick comparison with respect to the mid-drives, right? So if you look at Bosch, Brose, and Shimano, so if I compare with respect to throttle, customization, speed sensor, torque sensor, this is where Bosch, Brose, and Shimano fit in, right? We are the only one which can actually operate on a torque sensor, a combination of torque sensor and a speed sensor. We also have a throttle, and we can also do the customization, right? Bafang fits in here. Bafang is, we believe, all about raw power. They can only operate with a speed sensor, and they have a throttle. That's about their, so we cover the 4 areas quite well. If you look at Hill climbing. So hill climbing is the only area where mid-drives have an advantage. So you can see here, we will give them a high point. So direct drive, yes, today they don't have as much hill climbing capability as mid-drives do. So price-wise, quite high. Range-wise, they don't have the range because they don't have the efficiency. And speed-wise, they don't have the speed. We have the speed. So if you look at the comparisons, we beat them on all. Yes, hill climbing, we can give them a few points there.
Has anybody ever compared the difference, the strain on the drivetrain, the entire drivetrain with a front motor versus the reduction of the strain on the drivetrain with the rear motor?
Yeah, so I'm going to show you a slide here, Larry. So here is, so we talk about the stability on a trike. I'm not talking about stability in a bike. I'm talking about stability on a trike. So we think that our system is more stable on a trike, right? And to give you an example, so we talk about stability, comfort, speed, portability. So here is one question I like to ask. Are mid-drives stable for tadpole trikes? So here we have got how and who will answer this question, why mid-drives have been made popular for mountain bikes. The whole logic was that we are able to have lower center of gravity on a mountain bike, so we want to use mid-drives. Well, that kind of falls away, that logic, because if you look at the figures here, the mid-drives actually raise your center of gravity on a trike compared to a direct drive. So we question the stability of mid-drives on trikes. We also think mid-drives is blind leading the blind. And I'll tell you how the race started with the mid-drives. So today if you see mid-drives are expensive, they are highly complex, they have a very high maintenance cost, they are unreliable, and they're limited lifetime, right? And we have some data to show that to you. We believe that today mid-drives are here and the direct drives are here, right? And we do have a secret weapon, right? We do have a secret weapon to address that. So David and Goliath, right? The battle is on. So I'll tell you the story here real quick. So before the year 2011, we had mid-drives being used in Europe, right? We had a Panasonic mid-drive on a Flyer, and we had a Dom. They used to produce a torque which was only 25 Newton meter or so. They were doing fine. They were not putting any extra pressure on the drivetrain. Well, that kind of changed in 2011. When 2011, Bosch came up with their first drive system. So it was a 40 Newton meter. Slowly it has gone to 90 Newton meters, right? Because mountain bikes have become popular with the mid-drives, right? So it has required re-engineering all the bicycle components, including the chain, including the derailleurs, including the tires, etc., right? So this is, we believe, a commitment to a wrong solution. It's expensive, wasteful, and unreliable. Now, we think that the trend will reverse starting 2021 when we come up with our secret weapon. So today, and in 2018, we have seen the demise of Bionics and Go Swiss Drive, which has again added more credibility to mid-drive solution, but that's only temporary. So here is some more pictures I want to show you. So this is a Brose mid-drive, which is actually, they did something unique. They actually added a belt drive, a second, so you can see there is a control electronics, there's a motor. So motor has become bigger and bigger in size as the time has gone by. And you can see there's the first gear stage, the second gear stage. Now let me show you how the power is transferred in a mid-drive. This is the Bosch 2-gear stage, right? So you can see they have improved quite a bit. If you look at their first generation, the motor was very tiny. Now they have increased the motor size to decrease the load on the gear system, right? So if you look at, here are the issues with mid-drive. So we took the data. So here are our data sources. We went to electricbikereview.com and pedelecmonitor.com, we could see that the mid-drives, you have got mean failure point is 4,000 miles. That is when a mid-drive begins to fail. That is because you are using gears you're not supposed to use them. And you have a probability of failure, which is also plotted. So basically, you can see that the mid-drive, after about 11,000 miles, it is going to completely fail. The probability of failure is 100%, right? So here are some bicycle gear efficiencies. Again, I will be emailing this to you, but let me come to the conclusion. So we did the math. Here is the math we have done. We have looked at the chain tension, which is the point you were talking about. We have looked at the crank arm, etc. We've done all the whole math, right? And here are some numbers I want to show you. So a mid-drive motor can increase the chain tension 10 times. 10 times. And if you look at the power transmission efficiency of a mid-drive, the motor itself is 85 to 95% efficiency. First gear stage is 85 to 95% efficient. Second gear stage is 85 to 95% efficient. Derailleur is 85 to 95% efficient. So by the time the power is transmitted from the motor to the wheel, you're losing more than 50% of the power. So what's the point? Why have an electric motor which cannot transfer the power to the wheel? So you have 42% is the lowest efficiency, highest efficiency is 73%. Not good enough. We do cycling because we want to have more efficient operation. Power transmission efficiency, direct drive. So here is your efficiency. Power transmission efficient direct drive ranges from 68 to 85%. And if you're on a flat, it can go all the way up to 95%. Here is your power transmission efficiency of a geared direct drive motor. So you can see even that is a better solution than a mid-drive, where your lowest efficiency is 57% and highest is 81% because you have only one gear stage. Thank you. Here is the torque transmission. So you see, this is where the trick is played. This is called, I call this cheating, right? So you can see here, motor normally will produce 1 to 5 Newton meter torque. You have first gear stage, second gear stage, which will multiply 12 to 18 times, multiply the torque, right? You have a derailleur normally 1.2 times. Now, here is the trick. If I decrease the front wheel, I can actually increase the torque 3 times just in the bicycle, so I can play the game. If I give you a mid-drive with a small wheel, small front gear, then you can increase the torque 3 times. So all of a sudden, I can have a huge torque being generated with the trick I'm playing. So here is torque at the wheel can be increased to 270 Newton meters. So I can have a huge torque by playing some clever tricks with the mid-drive, right? So here, with a very smaller than a granny wheel, I can generate 270 Newton meter torque. And that's the end. Thank you.